Okay. All right. So, yes, good morning, everyone, once again, and welcome to today's class. So, in the last class, we started talking about a lot of things. So, we did a lot of this introduction in the last class, and we started with the properties of Rust. We talked about the data types, the basic data types. We didn't share more about the complex data types here. So we spoke about the basic data types and what's how they work in Rust. But before then, we talked about the properties and what makes Rust so preferred and highly talked about today. And it's because of the features it offers, right? So we talked about Rust being very strict, and once you have a programming language that is strict, it is good for it's good for sensitive programs, sensitive softwares, programs that can stand the test of time because we want them to do what they are meant to do, right? So it enforces you to follow a certain principle, a set of rules that, if followed, you can be sure that your code will perform the way it is supposed to. And then we said Rust is a compiled language, it's a low-level language. It is statically typed. It is very efficient. It becomes optimized and can perform faster. It is safe. So the safety of Rust is one of the very, very, very fundamental feature that makes it preferred. It is safe in the sense that it manages memory and it prevents you from doing or writing code in certain ways that can lead to memory issues. So it is very safe in terms of the data types from the standard library, from the core of the programming language itself. It enforces certain rules that does not allow you to break the rules of programming generally. So you can literally not write any bad code if you are writing in Rust. You can depend on your understanding of the language, but it is not common. Even as a beginner, you can be sure that whatever code you write can be seen as stable and safe. So, and another thing is that it helps you to, it helps you during debugging. It gives you good error messages, like very verbose messages. So those are some of the properties. And then we talked about the data types. So these are just overviews of what we did last week. The data types, the basic data types, mostly talked about integers, strings, the Boolean, and the bytes or characters, actually. So the integers, the strings, the Boolean. So we mentioned about integer types. We talked about the unsigned. Why we call them unsigned? Because they don't take any sign. So they start from 0. That means they can't go below 0 in the number line. And the maximum value you can have is 255. So that means the range or the total length of an unsigned integer for U8 is 256, 16 is 65535, 36, right? So, and the calculation is this: you start 2 raised to power the number of bits minus 1 to get the range of an unsigned integer, right? Depending on the memory size you want to allocate. And these bits are just the memory size that you want to allocate for the value that you want to pass into, or that you are defining the data type for this particular type. So you are creating a space in memory, right? You define whether you want it to have just the maximum value cannot go beyond 256, or the maximum value cannot go beyond 2656, or the same for for U32, right? So that's basically the idea about unsigned integers. Then we moved on to signed integers, talking about the difference between both is that the unsigned doesn't take signs, but the signed integer takes signs. But still, the range of values, no, not the range now, the length of values now is the same, even though the range may differ because the signed integer starts from the negative side of the number line to the positive side of the number line, but the length still remains the same. So then we talked about the Boolean types, which is basically just true and false, just as in any other programming language, right? Booleans are true or false, and you can see them as ones or zeros. One that they are true, zeros that they are false. So, and the default state for Boolean is always false because that's basically how it is. So every program, every computer state is always at rest. So for every Boolean type, the default value is always 0 or false. So that's. Now we'll talk about strings, and we say string is just a collection of arrays, a collection of characters, or an array of characters rather. So it's a collection or array of characters whereby each of the characters that make up a string now, right, is now what we refer to as the character data type in Rust. But the string data type is a combination or a collection of all the characters that make up a string. So in which case, if I want to use my name, just like an example, and I want to say my name equal to this. So for each of this value now, each of the character that make up my name, it is a character. It's a that each of the character that make up my name is the character, and the collection of each of those characters is my name. So now in this case, now M is a character, A is a character, Y is a character, O is a character, W is a character, and A is a character. So in this case, we have all of this, right? So a collection of these characters or an array of this character is what we refer to as a string, right? So this is an array of characters. So each of these are characters. Consider that I'm using a single quote, not the double quote. So the single quote there signifies that it is a character. In Rust, use single quotes to identify characters and double quotes to identify strings. So that is very important. So because when you look at Rust code, like some major Rust code, they are not difficult if you understand this basic concept. But like I said on the call last week, and as I always tell some of my Rust students also, that what they need to know about Rust is that as it is not difficult, right? It just requires a bit of more effort. And the effort there is consistency in practice. But before the consistency can come, you need to first understand the basic data types. So once you understand and you're familiar with the basic data types so much, you can then graduate into the advanced data type or the complex data types. But then you need to understand the simple ones and the set of rules. Once you understand those two things, the syntax, three things basically before you start writing your code, or two, yeah. You need to understand the syntax and the rules. And the syntax in this case starts with the basic data types, integers, strings, characters. Once you understand what they are being used for, because the bulk of whatever you write will still consist of these basic data types, right? But when you start working with advanced data types, they are basically a collection of these simple data types too, eventually, as we will see in the course of this series. So that's the advice. The advice is try to understand the simple data types as much as possible, and this set of rules, they will guide you and they will be your foundation for writing more complex code in Rust. So that's just that. And then after we explained all the basic data types, then we proceeded to talking about variables. But before then, we showed certain examples about the basic data types, printing characters to the string, to the compiler, how to write a function. We talked about the syntax for a function. The syntax such that you have your function keyword, which is your fn in this case. You have your add, which is your function name or identifier. You have your set of parameters, and then you have your return value, your return type rather, and then this is your body, the body of your function. And so you need to pass in the type or specify the type for the parameters and the return type if you are doing that in Rust. So Rust enforces you to tell the compiler that this is what I'm expecting and this is what I'm not expecting. So we did all of this last week, just a bit of overview, and this is our use of const. And one more thing about const is that when you define your const, you need to also specify the data type at initialization. So you do not, because you cannot reinitialize the value. So at the moment of defining or declaring and defining your data type, your const variable, you need to specify the data type for that variable. So that's basically the idea in this case. So these are all the things we did last week. And then we talked a bit about scope and how you can use scope in Rust. So just the general idea about scope also. This is very important. So scope is something we come across all through our Rust journey, right? Because you write a lot of Rust code where you will need to use scope. And a scope can be defined basically with just the curly bracket. Now, the reason for this is because if you look at this function too, what makes the function special is the fact that it has its own curly bracket, right? And whenever the compiler notices an opening and closing curly bracket, it takes it as a new scope and defines for it its own memory space. You can think of it that way. It defines its own memory space for it, whereby it executes whatever is in that logic, in the block of that scope. And then when it is done executing, it clears whatever is inside, makes a move of whatever variable needs to be moved, probably in memory, right? And then returns to the previous scope. So that's basically what the scope means. So if you look at this function now, I can write it this way, right? It's still the same as having it like this. So the idea of scope is that when you have two curly brackets within your code, you are simply saying that I'm defining a scope. You can't see my screen, Anulua. Can any other person see my screen, or is it general? Please, if you can see my screen, can you indicate, please?
I was able to please.
Sorry.
I can see your screen.
Okay. Thank you. So Anulua, can you just join the call again? Probably network issues. Okay, so that's basically what a scope, right, is in Rust. So these were the things we spoke about last week, and then we talked about the main function being the entry point to your function, and then those are just basic things. So today we said we are going to continue from the last class. I mentioned that we're going to continue from the conditional statements, because we already talked about variables, right? We already talked about initialization of variables, and we talked a bit about shadowing. I mentioned shadowing last week, whereby you can reinitialize a variable using the same name, right? But then you cannot assign a new value to it except you specify the keyword use of mute to your variables. So those are things we talked about Rust last week. So now this week, let's talk a bit about the conditional statements, right? So because we started with all the integers, the variables, the syntax last week. Now let's look at control flows, or conditional statements. So this is not too different from what we've done previously, but now let's see an instance. Let's see an example of this. So now I'm going to write a function to demonstrate this. So the function is just going to be using this example, right? So before I jump into the example, for those that are not familiar with any programming language, if this is your first, it's totally fine. What a new statement mean, or a control flow statement, is just a way of conditioning what your programming should do. So let's say you have a program that says that, for instance, now just like we have this call or this class by 8 a.m. West African time, you can have a condition within your program that says that at 8 a.m. to 10 a.m. West African time, class is ongoing. Any other time aside from that, class is not ongoing. That is a very basic structure of what a new statement is. It's a perfect example. So that means if I want to define something like that, I can have a function that simply says, so I can have a function defined at the top, or let me define it at the bottom of this control flow. And I can have a function like this that says, if a time, just like an instance. Now let's say current time. I'll just specify this as U8 just for example's sake, equal to 8, right? Now if I say if current time is greater than 8, or let's start with this first of all, then print live Rust class has started, right? I can now give a condition that is not true. Now, this is what I'm expecting to be true. I'm saying that if the current time is 8, that means if this is true, right, print the live Rust class has started. Else is now my false condition, or the alternative condition, or the alternate condition that I want to be executed if the first one fails. So in this case, I can say print line live Rust class has ended. So in this case now, if I run this program, if I run this now, what do you guys think is going to be my answer? Like, which of this code block, is it this one or this one? Which of this scope be executed? Now I'm going to write it like this just for, I know it's not the perfect way to write your code, like it doesn't give you that syntax, but this is correct. So which of this scope is going to be executed? This code block or this code block?
Parts.
Which of them?
Yeah, the current time is greater than 8. The live Rust class has started.
Okay, so you choose this. Do you agree with this? Does everybody on the call agree with this answer? just to be clear. Because I have a bit of, I don't agree with the answer though.
No, I think should be the second one. Life lost class has ended because the current time is not greater than 8.
Exactly. It's not greater than 8. It's actually equal to, it's actually 8, but it's not greater than. So you're actually correct. So if this is
Yeah.
equal to now, yeah, it will have been correct, right? So I just wanted to test you guys' knowledge on that. So it's clear that you guys understand this condition, right? So it's clear. So this is basically what we mean by a control flow. So a control flow allows you to define a condition that you expect to be true, right? So if I manipulate this and say this is 9, in this case, if I manipulate this by saying that this is 9, right? So this code will run successfully here. But what happens is, let's take it step by step and say, okay, fine, if it is 8. Now you see that whatever I've done in this conditional statement is just similar to what we've done so far from last class. If you follow the last class, or if you've seen the video, right? This is a function. We did functions last week. This is a variable, not too different from what we've talked about even this morning. And then the only difference here is just the way the if statement is written. Now, one thing to note is that your if statement does not take parentheses in Rust. I just added that for, kind of used to it from other languages. But in Rust, just like you have it in Python too, you do not use parentheses for your if statement and your flow, your control flows, basically. So we'll talk more about that. So now this is your variables, right? And from your variables, you initialize current time to be 8. Is not mutable, right? So it's just meant to be within this function scope. So that means the lifetime of this function only exists within this function, right? That is clear. You can see the scope again here. I want you guys to take note of scopes because it's very important. So, and then we have the current time, which is this. Then we have this current time check. So we are simply checking that, okay, if the current time is greater than 8, because that is what we want to work with, right? We are trying to create a logic. So, and that is the way to go about it. So, because one thing to understand about programming generally, and it applies to every programming language, just like I was explaining to some of my students from the React class, that for you to actually build or create a function, try to understand the logic first. So now let's assume I don't have this, right? And then I want to rewrite it. So what I'm trying to do is, I want us to walk through the logic one by one to see what we need to do. So I'm trying to create a logic whereby if the time for the class is between 8 and 10, then print that the class has started, right? But now this is just plain English, right? But if the time is not between 8 and 10, print that the class has ended. Now, generally, if you have been writing programs before now, if you have been, if you are familiar with any programming language, JavaScript, Python, C++, C, Java, whatever language, you probably understand the next thing to do straight. Or if you're not familiar with any programming language, right, you begin to think about, okay, how do I go about this? But still, that same knowledge applies even whether you are good enough with your other languages or not. So in Rust, what we do is, since I want to check a condition here, I want to check between two conditions that says that if the time for the class is between 8 and 10, print the class has started. Else, print the class has ended. So that's the way I'm going to interpret this. So I'm just going to use an if statement because that's the perfect thing to describe this scenario, right? So, but then before I define the if statement, I need to do something first. Now, given that I don't have this, but I have this problem that I want to solve. So the first thing that is here is that if the time for the class, so the first thing I need to do is, okay, what's the current time for the class? So then that requires me to define something that tells me what the current time is. That's the way I'm going to break the code down. So if I'm to break down this code now, the first thing I need is what? The time for the class. That's the first thing. So then I need to first define. So number one, define the time for the class. Or define or get. Let's see. Okay, so the first thing I need to do in this case is to define or get the time for the class. In this case, right? And that basically means that I need to first define a variable, since I'm saying I want to get the current time for the class. And that means I need a let and say the current time equal to, I'll give it a value just for testing it in this case. And then the next thing is, since I've gotten the time for the class, right, I want to check if it is between 8 and 10. I'm just analyzing how to go about translating from problem to code now. So if the time for the class is between, so I've handled the first part of the problem, that if the time for the class, so what is the time for the class? I've given a time for the class. Now the next thing is, if that time is between 8 and 10, so that means that between 8 and 10, I need to now check if this value, that is the current time, is between 8 and 10. So that means I need to check if current time, right, is between 8. That means it's greater or equal to 8. That's the first thing I want to do. So in this case, I want to start with 8 first of all. That's where I'm going to write this for now. And then I'll check this and say that, okay, I'll put it inside another scope, the logic for my code in another scope, and say that what I want to do within that scope is what? Print that the class have started. Okay, so I'm supposed to print now that the class have started. So that requires me to have a body that does something. So then I need to create a scope that handles the print line in this case, that says what? The live Rust class has started. So now I've handled these first two lines. I've done everything I need to do. The first thing is to check if the time for the class, what's the time for the class? I've gotten that, I've defined it. Now I need to now check if that time is between 8 and 10. So I'm using this for now, right? Then if this is correct, print this. So I've handled this logic also of printing this, which is this. Now the next thing to do is now to go to the next problem, which is, but if the time is not between 8 and 10, then print that the class has ended. So that means if it is not between, that means an else can work for me. And I can say print line, the live Rust class has ended. So that was just the interpretation of what I wrote before, right? And the interpretation of the problem that we are trying to solve from here. So this is how you interpret your code. I know this is a simple one, but then when you have complex code to interpret, it's best to break it down in this manner. Once you break it down in this manner, you will be able to write proper, code, structured ones, because you already know that, okay, you're defining your variables, you are defining all the things you need before you start writing. So that way you already know what you have to do, even visualizing it already before you start writing your code. So this is basically what we did. So, and this basically explains what a control flow is. Now let's see if you can get an example from here. Yeah, so we have something similar, but in this case, they are using less than 5, but we are using the real life scenario of the class to explain this. And is there a question? Yeah, Shaibu, go ahead.
Yeah. Hello, sir. Can you hear me?
Yeah, I can hear you clearly.
All right. So I just have a question, sir. So for the condition, you said if the class, if the time is between 8 and 10. Now,
Yes.
Since in the condition you are just handling if the current time is greater or equal to 8, what of if the current time, maybe let's say is 11, does it handle for that condition of 10?
Okay, so currently we are not done with this code, right? Thank you for the question. Yeah, so what I was supposed to do is, I said I wanted to just write for this yet. I've not covered for this yet. So what I was supposed to do is, if the current time is greater than or equal to 10, you know that from the initial problem, right, we wanted to check if it is between 8 and 10. So what we need to do is check if it is greater than 8, right? So that means we are trying to check for a range. The reason why I didn't write it directly is I'm trying to explain this now, is that we want to check between 8 and 10, right? So that means, this simply means, if I'm to interpret it, the time must be greater or equal to 8 and must be less than or, let me break this, and must be less than or equal to 10, right? Now, if I'm to interpret this between 8 and 10 now. This is the interpretation in English. Now, let me interpret this English back to code now. It simply means that the current time must be greater than or equal to 8 and less than or equal to 10. I've done the first one, which is greater than or equal to 8, right? Which is this. So now the next thing has to be or, because let me use the or sign, or current time, right, is less than or equal to what? 10. So that's basically what this condition is. So now in this case, now to answer your question, Ashaibu, based on this condition, no, we've already scoped already a limited range of what this will do between 8 and 10. Right? So in this case now, this is how you define your or in Rust, using the two pipe, and this is how you define and. So now this simply means that I'm saying if current time is greater than 8 and current time is less than 10, print what? The live Rust class has started. I don't know if that makes sense. Does this answer your question? Shaibu, are you there? Okay, all right. So this is how we are supposed to implement this, right? So now we understand that from the control flow, we are saying if the time for the class is between 8 and 10, something should happen. Now let's try running this so that it's not just word of mouth, right? Let's actually run this, add this to our main function. Like I said, and like you understand already, your main function is the entry point to your Rust program. So everything you want to execute need to be within your main function one way or the other, whether by imports or by initializing it or by defining your function in the same function and the same file or external files. Everything has to be or start from the main program. That's the way Rust is built to work, right? So now let's try running this. We have. So in this case now, we say, let's check the value. Now it's giving me the live Rust class as started. Now it's because the value is still between 8, right, and 10. But what if I make this 11, right, and then I run this again? Obviously going to be the Rust class has ended. So now this is a simple case of a conditional statement or a control flow, and these are certain things that happen when like you have things like let's look at a real life scenario. Let's say we have a time-based exam whereby you only have 30 minutes and you must have taken an assessment like that whereby once it's 30 minutes you can't access the exam again, right? Now what is basically handling that logic is they are checking the current time. Once the current time is less than the time specified, that you should finish the exam, you have to continue taking the exam. But once it is greater than that time, you have no ability for that system or that platform to continue the exam. So now what handles those kind of logic is just an if statement. Now, as simple as this may seem, it can be extremely powerful and complex. So when you are dealing with much complex logic, just understand that at the end of it is basically just a control flow. If the logic is a control flow or a conditional statement, what you need to do is first dissect it like the way we did this problem, and then start breaking it down little by little. Then you probably understand that it's just what it's supposed to be. It's just as simple as it should be, right? So I just wanted to give that analogy because though this is not complex, but it will help you if you implement the same logic for complex problems, right? So that is important to know. So now that's basically what an example of control flow is. Let's look at another example whereby also before then we can also pass our control flow to an expression, kind of something like this. So let's say we have we can use it as an expression in this case, right? So now if I want to specify, say I want to get your is above, let me use the convention, or let me say can vote in this case. Now can vote is in Nigeria, for instance. Now you have to be above 18 for you to vote, right? So I can say can vote is a Boolean expression, right? So now in can vote here can be true or false. right? This is what I'm expecting because it is a Boolean, right? You already understand this. Now, there are two ways to write this. I can define this as false first initially and say if, now this is a conditional statement. If, then I need to define another variable. Let's say I want to check. Let me give you an instance. Now, let's say I want to define a condition whereby someone can vote. Let me move this outside. Right? Let me move it into can function can vote in election. Right. So let's say I have this function that checks if a user can vote. Or let me say user can vote. I know this is very verbose, but just bear with it. I'm trying to explain the point. So let's say we have user can vote in election as a condition, right? That we want to check. We want to have an utility function or a function within our logic that checks if a user can vote in an election. And we know that the voting age, the minimum voting age is 18 years old of age, right? So what I need to do is if I say, there are two ways to do this. I can say let's can vote, which is a Boolean, equal to false. That means by default you cannot vote, right? So now I need to first check. Now, okay, before that, let's try to write our problem out, right? Check if this function checks if the user can vote or not based on his or her age. Now, that is what we want to achieve, right? We want to check if the user can vote or not based on his or her age. So now, how do we break this program down? The first thing we want to do is we want to check if the user can vote. Now, based on what? His or her age. So that means we need to have the age, right? So that's the first thing that this tells us. So we need to create a variable called age. So age is going to be, let's say U8, because we assume everybody should be below 256 years. And then we can say age is, let's say 9 in this case, just an example. Then we want to check if the user can vote or not. So how do we check that? Since there are two conditions now, we can use a new statement, right? And a new statement can be if, don't forget we don't use parentheses, if age now, right, is less than what? 18. So it means that what the user cannot vote, right? But in this case, we want to check if the user can vote or not, based on this age. So that means there are many ways we can do it. We can return true or false, which is the logic we want to go with. So we want this function to return a Boolean for us. So in this case, I need to specify what? Excuse me. I need to specify the return type, right? There's one way to go about it. Now you see how we are building the function little by little. Started with just defining the function name. Then we define the variable. Then we define the conditional statement. But then we realize that in the conditional statement, we want to return a Boolean. So what I did was now, okay, go back to add this to it. And now you can see how you are building your code little by little. And before you know, if you have to actually implement something like this, before you know, we are already writing 200 lines of code, 300 lines of code. That's how you build your program, and that's how you write your code. So now, in this case, now we already specify we want to return a Boolean type. Excuse me. So the next thing we need to do is if it's less than 8, right? We want to return false. Now I can return this like this, or I can return it like this. You know that Rust allows me to do any of them, but I will return it in a verbose way. But when we start writing more bulky lines of code, we start shortening what we are writing. But for now, let's leave it like this. And then else, I'm going to return what? True, right? In this case, I'm simply saying that if the age is greater than, so this one says if it's less than 18. So that means any other condition, right? Any other condition will return true, that you are greater than 18. That means you can vote. Now, this is one way to write this function, to write the logic, right? So in this case, now, if I call user can vote, and the user is 9, it's going to return false because the user is less than 18 years of age, which is valid. Now, there's another way you can write this in Rust. You can do something like age, let's can vote as an expression. Now, you know that this is just a complete line of code. This is valid, it will work fine. But I want to write it as an expression. I can say if age greater than 9, right? I'll just return what? In this case, greater than 18, right? I'll say return true. Else, return false. Now, this is also another way I can write it, and this is valid also. So, what this means is that whatever value is being returned from here is going to be passed into can vote. So, at the end of the day, I'm going to return what can vote. But this is not meant for functions. Like, it's not meant for function, because in the real sense, this is what you want to write if you want to write it in a function. But let's say you also want to write it as a line of code or within a scope, right? You can also define your if statement like this. It's good to know. It will save you a lot of time when you write your code eventually, because you can just pass it into a variable, then use it outside of the scope. It's very easy. You can just do that, and you can do variable shadowing in this case, and then it just makes life easy for you. Then you continue without needing a function every time. So this is one way to go about it. You can write it as an expression, or you can write it as pass it in a function, and this works fine. So this is what we have, right? And this perfectly works in this case. But then this is what we are supposed to write here, right? So that way you are simply saying that turning the value to can vote, and then that's basically what you have. So now you can write your if statement as in an expression, right? So this is as an expression. Right, so you can write it this way and it's valid too. So now let's check, let's try this out. Let's try this value. Let me copy this and then try it from the main. So then we need to specify our age also, equal to, let's say 9, for instance. So then let's see what we get from can vote. So in this place, let's print line. Can user vote? So we can say can vote. Right. So this, once you see a syntax like this, it's a valid syntax in Rust. Like, it's perfectly valid. It's just an expression. It's just a new statement as an expression in this case. So now let's try printing this and see what we get. Oh, expected this. So what did we get? Where is that error coming from? Like 118. Oh, yeah. You're supposed to, now because it's an expression, I'm supposed to end this with a semicolon. Now, remember what we mean by an expression is if I say something like let's name, right, equal to Mayowa. This is an expression, right? This is an expression. So in this case now, I need to also end it with a semicolon. If I don't, you know that you end every expression with a semicolon in Rust. So because this is an expression, you need to also end it with a semicolon, whether it has a for loop, a new statement or not. As long as it's an expression, you have to end it with a semicolon. So that's why it was throwing the error. Right. So and you can see once again that Rust is giving us perfect and beautiful errors. So we can understand where it's coming from. Expected print line. Oh yeah, I didn't have the same thing to this because it's an expression, right? Now let's try running this again, and then it should be fine. But it's telling me, it says unreachable statements in which of them? Yeah, for the function we defined earlier. So it says can user vote? It says false because what? The user is not greater than 18. So you can see that this works perfectly, right? It works perfectly. So that's another way to write your if statement. You can write it within a code block. You can write it normally, and you can write your if statement as an expression in Rust. It's perfectly valid. So this is an example. So let's try to solve this problem, right? Let's see a solution that we can solve here, because that's the essence of using 100 exercise to learn Rust. Then we can solve this. So because when you say exercises, you want to try to solve it. So in this case now, let's try solving this. The exercises are contained within this live.rs. And so if I go here, okay, so now let's try to do this, right? So we want to check this function that is called even, right? So that's an example. So now let's check. So what we need to do in this case is return true. Let me copy the comment with it. It says we should return true if even or false otherwise, right? So how do we do that now? So how do we do this? This is where we want to write our logic. How do we implement this? Let me move this out. Sorry, are we following, please? Anybody lost at this point? Anybody confused? I can know that we are following. I hope it's not too confusing at this point. I know there's a lot of things, like I said last week, because there's a lot of rules and a lot of ways of doing things. So just try to follow. If you're not clear, please just point me back so that I can go over it again. Right. So can we give vote type a data type of bool since it's returning a variable? Oh yeah, sure. You can do that perfectly. So that works. So Shaibu, yeah, I've answered your question. And so Judith, it says, why is it called an expression? So in this case now, like I explained the other time, if you have something like this, whereby this is an expression, right? Now, the reason why it's an expression is because you are simply expressing that this guy, I'm saying the literal term now, is equal to this guy. Now, there are certain things called statements and there are expressions. Now, expression, you are simply expressing that this value, that's the easiest way to understand it, right? You are explicitly expressing that this value is for this variable. So whenever you see something like this, just understand that a variable initialization is mostly always an expression. Right, so okay, so let's proceed. All right, so now let's try fixing these errors. Who can try to help us fix this or help us complete this problem? Whereby we have return true if it's n is false, otherwise false. But if n is even, it should return false. Oh, sorry. If n is even, return true. If it is not even, return false. So who have an idea? Who can help us? Anybody wants to try? Or try it? Okay, yeah, Shaibu, go ahead.
All right. So I'm just thinking, and okay, this is a question I have first. Does Rust have a functionality for modular division?
Yeah, it does.
Okay, so I think what I'm actually thinking right now is first to use modular division, and if 0 is returned, then it's definitely an even number. Otherwise, it's not. I think that's just my thoughts.
Okay. All right. Okay, so let's go about that. So we are saying that if n, let me just try to understand it. So if n modulo 2, for instance, since we want to do modulo division, right? Okay, so if this is equal to 0, is that what you're saying?
Yes, sir. Yes, sir.
All right. So we can simply say this actually. So we can have we can return an expression that does this. So we can have, just like we did for something like this, for this voting election, we can have the same thing here. So such that when you pass a value, you want to check if no parentheses, sorry, I'm used to that from TypeScript in JavaScript, is greater than or equal to 0, right? We want to say that what we want to return true, right? Or we can say that else return false. Right, let me just write the variables. So this is basically what we want to do. So now in this case, now we've successfully achieved this. So what does this mean? It simply means that when you return a modulo, because if you look at it this way now, if I have a function like, if I have a number 5 divided by 2, right, or 5 modulo 2, right, because the modulo sign does not give you the result of the division or the remainder. So 5 modulo 2 is going to be 1, right? 4 modulo 2 is going to be 0. Now, that means that we can perfectly use the modulo sign or modulo division to check for even and odd numbers, because we are very sure that for every odd number, you're only going to get 1. If you try using 3 also here, for instance, if you use 3 here, you are going to get 1. If you use 2, you are going to get 0. So that means for modulo functions, If you try 6, you are going to get 0. That means 6 divided by 2 is 3 with no remainder. 5 divided by 2 is 2 with 1 remainder. 4 divided by 2 is 2 with no remainder. 3 divided by 2 is 1 with 1 remainder. So that means for every odd number, there's going to be a remainder. Therefore, so we can use that to check for our number and odd numbers, such that that it is an even number. I don't know if that makes sense to us. So that's what Shaibu is trying to explain. So I think that makes a lot of sense. So yes, that's about if statement. A lot more about if statement now. So let's go back to so we're done basically with the control flows for if statements now. We're done with if statements. So that's basically all you need to know. Use operators, greater than, less than. We don't use some of them, but still the same approach depending on the logic, right? So you see how to use it using truth values, see how to use it using this kind of expression or as an expression generally, using this type of logic, or you have it as an expression. So it works in both ways and it still works perfectly well. So let's go into panics, right? Let's consider panics now. So what we are trying to do in this case is that what does panic do in Rust, or what is it used for? Now, just like the name implies, it's almost everything in Rust is literal, right? Panic simply means you want to panic within your code. You want to send a panic to the user, right? The compiler you want the compiler to send a panic to the user that something has gone wrong. That's basically the meaning. So whenever you see a panic within your code, you are simply showing, or you are simply telling the compiler that, okay, send an error message back and stop execution of this program at that point. So that's basically what a panic is. A panic in Rust is also a macro. Just the same way we have I think I mentioned what a macro, that we have macros in Rust, but we'll come to talk about them eventually. So so now let's look at an example of panic in this case. So let's pick this example and try to analyze this example. So we have an example here called speed, right? So we've done a lot of if statement. Now let's pick this and call it panics. Now in this case, now we have an example of function called speed that takes in one or more parameters and returns an integer string type. Now, in this case, what we are trying to achieve is, now let's try to analyze this code, this program. I have a function called speed, right? In this speed now, I have a start and I have an end and I have the time elapsed. And then what this means is, what is the distance by which I traveled? The distance I traveled is what? It's by subtracting the end value from the beginning or the start value. And then I can get the distance. So then let's say I want to know the distance I traveled between, let's say I traveled 10 kilometers and I started from kilometer 1 or 0 kilometer, right? If I subtract this, if I subtract this now, I'm simply going, because this is the start, let's say this is the start. Let's assume that start in this case is equal to 0 kilometer and the end, just an example in this case, equal to 10 kilometers. Now my distance in this case, I've traveled down kilometers, 10 kilometers, literally, that's what it means. So my distance in this case is equal to what? 10 minus 0 kilometers. So that means I've traveled 10 kilometers in my journey. Now, what speed? I'm going to calculate the speed I have used to travel. Now, I'm trying to explain what we need to do, because in this function, I want us to add panics as much as possible, using everything we've learned so far, using the variables, the conditional statements, the control flows, everything that we have used to actually return panics, because we have more than one from our own observation of this function that we can return. So what that means is, from distance, you can return, now we have our distance to be 10 kilometers, right? Now I want to get the speed. Let's assume now this is what we want to calculate speed. So the speed now will be the distance traveled divided by the time spent, or the time elapsed within the journey. So let's say the time elapsed is, let's say it's That means I use 5 minutes. Let's assume I use 5 minutes. So now to get my speed, it's going to be 10 kilometers divided by 5 minutes. That means I spent just two. Let's say I run at a speed of 2 kilometers per hour. Let's assume, just take it like that. It's not correct, but you get what I mean. Just take it like that. 2 kilometers per hour is going to be my answer, right? Let me strip away all this. Okay, so then in this case, now you can understand that the speed is going to be 2. Let's say 2 kilometers per hour by assumption, right? Exactly. So now this is what this program is talking about. This function speed is just trying to explain. So you can use the end value, the start value, and the time elapsed to get your speed, and then you can return the value of this speed as this, right? But there are problems within this code. We can see any problem within this code, because let's say I'm to pass in parameters, right? So can you see any problem within this code that you feel like we need to take care of first? That we need to, or any error that if it can happen within this code if I'm passing like variables. Anybody wants to try? So okay, if time elapsed is 0, exactly. So now if the time division by 0, yeah, perfect. So now division by 0 is going to be a big problem, right? Because in this case we already have division, which is by 0. So that means let's try to catch this error and do something like this. Now, for us to check the error, we need a conditional statement or a control flow, right? And that's why the control flow comes before this, kind of like to build on what we know before. So now if in this case now we say our time elapsed, because the time elapsed is the denominator in this case. So we have the time elapsed equal to 0, right? I'm going to move the bracket. Sorry, I'm so used to bracket because of JavaScript and TypeScript. So if time elapsed is equal to 0, what this is going to mean is that we want to panic. How do we write our panic? We write it like this. Just you write panic as a word, then you add the macro, the exclamation mark to signify that this is a macro. So in Rust, anytime you see the exclamation mark, right, it simply means it's a macro. So you can notice the macro also in print line that we use. Or if you're using a library, even if it's an external library and you see this print, you see a macro like this. Let's say I have a library called Mayowa like this, and I have this. This is a macro. I can define my macro, but don't worry, we'll come to that eventually, right? Because of this series, we'll define ours, but that'll be later on. So this is just a macro. So now we have panic as a macro. Then panic takes in an argument of the error message that I want to return to the user. Now, in this case, I can return to the user that time elapsed cannot be 0. So that way, if the user passes in 0 as the time elapsed, this is what will be returned to the user. So that means the compiler will see this as, oh no, this is not possible. So the compiler will panic with this error message to the user, and the user will see this as a clear and defined error. Now let's try this out and see. But that is not the only problem. We can see another one because I can see 2 problems. So exactly, can be a challenge. So perfectly. So those are the 2 errors that can occur, right? So if you consider this also, so if you consider the fact that we can have the errors from the end statement too. So now let's say we have end, right, to be, sorry, excuse me. So we can have the end. So yeah, so we can have the end also to be like, if the end is less than, right, then it's going to be a problem. But because we are using the unsigned integer type, we are sure that the user can pass in a negative number to any of them. So that can be, that can be reduced. But it starts by 8 a.m. West African time. But so yeah, so now time to fix this, catch the second error. So now let's say we know that the first one is check that the first error is check that time elapsed cannot be 0, right? That's the first check. Now the second check is what? Check that end time end must be, check that this must be greater than start. Now, the reason for this is you are sure that for every time you run this code, right, or for every time this code runs, for any reason, you are very sure that this is going to happen, right? The end supposed to be greater than the start. That's the way it's supposed to work, like by default, because where you are going to should be longer than where you are coming from. That's basically the way it should be, right? So in this case now, okay. So in this case, it means that I need to check that the end that I'm passing in from my parameters, I'm going to pass on as an argument, must be greater than the start. So I need to say all right, so sorry for that. So if I say the end must be greater than what? 0. So sorry, it must be if it is not, or if it is less than, is it less than or equal to? Which one should we use? Considering the logic, let's think about it. What is responding? Okay, so basically what we are going to do is we can use the less than, right? So if end is less than start, right? So but in this case, what if it's equal to end also? It's equal to start. What happens? It can be a problem because then it becomes 0. If you subtract, let's say it is 0 minus 0, or let's say start is 1. 1 minus 1 becomes 0. Then 0 is the distance. That's also a problem. Because you don't want 0 to be the numerator, and we don't want it to be the denominator. So we need to say equal to, not just less than. Do you get it now? So if end is less than or equal to start, we want to panic also. Now, do you see the way we are analyzing this program now and then building code for it, like building code blocks for it? So now panic is going to return end value must be greater than start value. So in this case, we can be very sure that our code will not have an issue of the end being greater than the start. The start being greater than the end for any reason. I don't know if that explains this, right? So what other check do you think we can handle here? Because we've already handled these 2 checks. We've checked for the time, the 0. We checked for the division does not return a float. Okay, nice one. So we need to check that it does not return a float, right? Okay, so now how do we check that? How do you suggest to check that, Shaibu? I'm not talking about floats in this place, so I don't want to mention it yet. Excuse me. But then how do you suggest we go about it? If you have an idea, tell us. All right. In the actual sense, it's for now, right? Since you don't want to talk about float now, let's just assume that it's going to be U32. Let's use U32 for now. Right, let's just go with that. Because in this case, even if it returns a float, right, it's going to return a value for us. So let's go with that. When we start dealing with float, we still pick an example that works similar to this. And then we slot it in. But for now, let's just stick to this unsigned integers, since every value, every argument that we are passing to this function, they are going to pass to this function, is expecting an unsigned integer, right? So this is a very valid one. But what I will do if I'm the one writing it is not to ensure that it does not return a float, because I may want to return a float, right? I'm talking about the speed in this case. So that's not really a problem. You get? So, but then what I will have done is to convert it from an unsigned integer to a float data type. Like I said, we've not talked about that yet, so I don't want to jump into it from here. So, but now you understand what this is. So let's talk about panic and just move on. Then we'll come back to the float type and then we'll talk about it. So now this is basically what we have. So we've added 2 checks to our program to make sure that this code cannot be a problem. Now let's try testing it. Let's add speed, right? Let's say speed is, we're expecting 3 parameters, right? We're expecting the start, and the start is all are U32. So now let me just print this and see the result. Now you can see this is a macro also. I'm using the I'm using the exclamation mark. The speed run is, so let's say the start is 2, the end is 10, the time elapsed is 5, right? Let's see what we get in this case. Hey, Judy, you are coming to macro. So we are going to talk about macro like extensively. I'm still going to talk about it. I probably want to show you instead of just like explaining it. So I will show you through the Rust book. Where is it again? Yeah, we're going to talk about macro here, but then we are not there yet, right? But the simplest way to no worry, we'll talk about it. Just let's continue from this first. So we have this. The speed run is this, and we have 2, 10, 5. Now let's try a function. Remove all of this on this. What is it? Okay. Okay, so the speed run is 1, right? Let's calculate to see if this is correct. So what I was supposed to get, first thing we're supposed to do is, okay, let's make a mistake somewhere. Right, let's make a mistake somewhere. And let's add this to be 0, the time elapsed. And let's try to run this function. Now you can see the code exited with status 101. Where is the error? Now you can see the error here. It says what? The time elapsed cannot be 0. Let me try removing all this warning so we can see the actual errors, right? So all the code block I'm not using, I'm just going to take them out. Can use our vote in elections, all of these functions that I'm not making use of. Even this. So I'm going to take this out. I'm just going to comment this. And I'm going to comment this also. I'm going to comment this also. Yeah. Okay. So also go here and let's see. Okay, let me try run this again so we can see the example, the errors. Now you can see this error here, right? It says cannot find. Oh no. This, okay, that means I was using the control flow there. So let me leave this uncommented. All right. So let me run this again. 161. The name is not being used. Okay. So I was using this to explain shadowing that day last week. So we are not using this anymore. It's going to try the error here. So let's run this again. There's another one use code here. Let me just remove this first of all of it first. So sorry about that. So we can focus on what we're actually talking about today. Okay. All right. So now let's see this. Let's see what we have. Wow, the one is just don't want to go away. You can see we have this. The time elapsed cannot be 0, right? And the reason for this is because I said the code should panic, right? It should panic because the time is 0. The time elapsed that we added is 0. But excuse me, I don't want it to have 0 at this point. So that means if I make this also greater than the n, right? And let's make this 4 in this case. Now, if I use this, because the start is greater than the end, we are expecting another error to be displayed, right? So now let me try running this. In this case, now we have this error that says what? End value must be greater than start value. You can see what it says. It says that the finish dev profile, okay, all of those things. I talked about the dev profile, right? I think that was last week. The thread main panicked at the line. It will tell you the line where the panic occurred, right? That's how Verbose Rust errors is, and it will tell you what the problem with this is. So we can see that the problem with this is that end value must be greater than the start value. I don't know if this makes sense, right? So this is basically what the panic helps you to do, right? So it's one of the ways you can break. And one thing to notice is that it breaks execution of this code. Now, one way we can test that is let's see this user can vote. No, user can vote supposed to come last, right? Now let's test that. you can see that it doesn't get to user can vote. It only stopped at the live ROS class, which is control flow. It does not get to this point because wherever the compiler meets the panic, it's going to automatically break the code. Now let's even test it and see, not to print out the live ROS class has started. So let me move this out and add this here before the control flow. So it will not get to this control flow. It's just going to break the code at this point. At this point, rather. So now let's run this to see the execution of this, and you can see that it does not even print out anything, right? Because at this point, the code is going to just break. It's going to stop execution. The compiler has received a panic statement, right? So it's going to break. It's going to break out of the execution of this program. So that's basically what panic does. So panic will break out of the execution of the program and still display an error as to why the break happened, right? So yes, that is panic for you, and that's basically all you need to know about panic. So now for the Rust book, let me open this to show you something. Okay, don't worry, we'll talk about this. We've not gotten to results yet. When we talk about results, I think we can then compare that. So, yes, what's that? Okay. So now, for Jude, I was asking about macro, right? So you can see they are just functions. Like I have not mentioned that they are functions, but like I said, we'll cover them in other in later series. Let's not jump into macros here, but just know that they are functions. They are just functions. The only thing that makes them different from regular functions is exclamation mark, right? So we'll cover them. No worry, we'll talk about them. They are interesting to have. You can write your custom macros to do what you want, but that's the beauty of Rust, because it's low level. You're able to do almost everything. Like you don't get to do that as much in. And there's a problem. You can do that in other high level and on and write your own of methods, like building on the standard methods and libraries like strings, like integers, just the way you use prototype in JavaScript, right? But in this case, you can do something much more powerful using Rust because it's more low level. You get so macro is one of those things you can build to do stuff and extend library, the standard data types, rather, to do what you want. Similar to what you can do in high level languages. So it's quite interesting. We'll get to that eventually. So let's move on to let's start Factorial now. But Factorial will help us to understand. Okay, these are just exercises for now. We'll come to this eventually. So let's go to loops, right? So for loops, we are going to talk about while loop. Now we've covered the if statement, conditional statement, if statement, and else statement. And we can also have the else if. I forgot to mention that, but still what it is. But let me just touch on it before I move on. So for the if statement that we have, for the if statement, now let me just touch on that quickly. There's something I want to point out there. So for control flow, right? Say I want to have this. I want to have another condition that checks if, but I want to have another condition. If the time is between 4 and 6 p.m., right? 4 and 6 p.m., then print the time is for React classes, not Rust classes. Now, this is another condition. Now, that means I need to have another if condition. But what do I want to do now? And I want to use this new one called else if. Now, else if in this case means that else if this is greater than between 8 to 10, and do this. Else if it is between what? If current time is greater or equal to 4 and less than current time equals to 6. Just like, okay, so in this case, I don't want to use 4 and 6. I want to use the 24-hour format. So it's going to be 16 and 18, right? So now, the live class is now for React. Cross class has ended. Now, something like this, right? And now this basically means that the way this works now, you can see that this the if statement, then the else if statement, then the else statement. Now you can also look at it as if and else, but let's leave that for another time. What you just need to understand is that you can have multiple conditions, and in this case, the multiple conditions. Wait, my screen is not being displayed. Wow, what happened? Network. I guess. Okay, it's back. So in this case, you can have multiple conditions, right? The first condition is this, which is 8 to 10. The second condition is what? This, which is between 4 to 6 p.m. Then this is the last condition, which is just if none of this condition is satisfied. So you can have multiple conditions. You can have multiple nested if statement also. I can check if it's between 8 p.m. to 10 p.m. All of those conditions. So you can just have multiple nested conditions. So I just wanted to point this out because I didn't mention the else before now. So that's how to have your nested if statement, right? So yeah. So another thing to know is that if you have your no, we can have loops also, right? So now that's that for condition now statements, which is control flows. Now let's talk about loops. Now there are different loops in Rust, just like we have in other languages, where you have your while loop. In other languages, you can have your while loop, your while do loop, right, and do while loop. Some languages are that's funny. JavaScript, we have that. And in Rust, we also have the while loop, right? The while loop in this case is a way to continue execution of a code, whereby you just want to say why something is true. The execution should continue. So you want to execute a code block as long as the condition is true. That's basically what a while loop does. And that's why you use it, or why you have while loops. So you can use it for continuous execution of a program. So now let's see the way it is written. Let's just consider an example of a while loop. So I'm going to have, in this case, right, I'm just going to pick an example here. And this example is what we are going to analyze. Now, we can copy this and just have hit here like this. So what do we want to do in this case? Now let's try to analyze this based on the comments that we also have. Now we can read this code now and understand it, since you are already getting familiar with Rust syntax. So now this basically means that we have a let, right? That's the first thing. And the let in this case is a variable. So we have a variable called sum, which is 0. We have a variable called I, which is 1. Then we want to check that while this I, which is equal to 1, is less than or equal to 5, right? We want to increase the value of sum, which is 0, right? And then we want to increase the value of I. So what this means is that we want to run this condition. Now the condition is where inside this code block. You can see the scope again, right? It appears everywhere, like I said. So this scope is meant to handle code logic. Anything you have within a code block handles code logic. It just is used within the body of the function, or it contains the body of your expression of your logic. So in this case now, while I is less than or equal to 5, in this case, we want to say that always run this logic. So what will happen is that the first time it gets to this point, first check if I is equal to 1, right? This is the syntax for while loop. You write it like while, like this, just the same way you have your if, and then you define your condition as sum is greater than 0, right? Then you have your code block, your scope, right, for that condition. The same way you have your while loop also, like this. You start by defining your while loop like this. You define the condition that you want to specify like this, and then the body or the body of the condition you want to specify, or the body of your logic be contained within this scope, and that's it. So then just the same way you have your while loop, you can have your for loop, you can have your if statement, all of those things. So then that's just the general syntax. Syntax are familiar. Once you understand one, you can use that to approach the other ones. Right, so that's what we have. So in this case now, I want to try to implement this. So we are simply saying that why I is less than 5. Let's try writing this ourselves. I'll just copy code. So now I want to execute this problem, So I want to have a value between 1 and 10, right? And say while, see that it's kind of literal, right? So while the value is less than 10, add the previous value to the next value. This is what we want to do. So the first thing we need to do is we need to have two variables now. Now, how do we go about this? The first thing we need to do is have a value between 1 and 10. So that will be what I will use to store my value. So I need to have a value that holds 1 to 10, or that's help me manage this condition. So the first thing I'm going to do is I'm going to define a value. I'm going to call it val, in this case, equal to 1, right? And I want to say, second, that's the first thing I want to do. Now, why the value is less than 10? That means why this condition is less than 10. Add the previous value to the next value. So that means add, in this case, means I want to sum. So I can say, let's add that, or I'll just call it sum, equal to 0, right? Now, I'm not saying that while value, what is the value here? I didn't get a message. Why declaring a variable and the size of data type is not specified? What we did is default data type size. The size of data type. Oh, okay. So for an integer type, it's going to be U32, right? For an integer type, by default is U32. I mentioned that last week. So if I don't specify like this, it's U32. But then if I specify, is U8. But by default is U32. You get it? So now I know that I already have this saying that while the value is less than 10. Now I need to check that why this value is less than 10. So what do? I use my while loop. So now what you need to use from your code will depend on the way you interpret the problem. Now I want to interpret this. I have a problem that gives me this to execute. The problem already gives me while, like it's already a literal statement for me. So I know what to do. I'll just go to use the while keyword and say that while, what's my condition? The condition is what? While value is less than 10. So I'll just pick value less than 10 like this. Now that's the condition. That's the only condition I have, right? I don't have any other condition. So that means I'm done with writing the condition. I will now go to executing the code logic. Now, what's the logic I want to implement? Add the previous value to the next value. That's the next logic. The next logic simply means add the previous value to the next value. Where is 19? Did I include 19? 10. Let me see what Jude is asking. Why aren't we including 10? Oh, okay. So the reason why we are not including 10 is because we want to go between 1 and 10. And the condition says that why the value is less than 10. So now we can have 10 here also. Okay, you can have something like this. Have a value between 1 and 10, right? So you can say minimum value and maximum value. What's the maximum value? 10, right? Is this fine? Jude, I think this clarifies what you want. So now we already have two values that goes what? Have a value between 1 and 10, right? So now in this case, I'm defining a range for the value. I'm having a minimum range, a lower range, and an upper range, right? And in this case, I say my minimal range or my lower range, let me call it, the minimum value is 1, the maximum value is 10. So my condition simply says that if my minimum value is less than maximum value, right? In this case, which means that if the value is less than 10, right? Then add the previous value to the next value. So that means, what is the previous value now? The previous value is what? Which is the minimum value. I'm going to add it to what? The next value. So that means I need to find a way to store the minimum value, that's the previous value first, before adding it to the next value. So, and that is where the sum comes in for me, because I'm using add. So what I'm going to do here is I'm going to say sum equal to what? Minimum value. I'm going to be adding it to what? To the next value. The next value is what? sum plus 1. Oh, okay, this is a bad way to write this expression. What I actually wanted to do is add it to, okay, this is not a for loop, so it's not going to work in this case. This is a bad way to write this. I should have rephrased this a lot. What do I rephrase this? How do I rephrase this? Okay, add the previous value to the next value. The previous value in this case now, the previous value in this case is the minimum value, right? Is equal to sum plus, let me just work with this. I'm not rephrasing it. The minimum value before initially, right, is equal to, so I'll just assume that the previous value is equal to sum in this case, and the next value is my minimum value. So what I want to do now is I'm going to change the value of okay, yes, let me just work with this for now, right? I think this best explain what I've written. I don't want to change what I've written already, so let me just work my logic around making it work. So now what I'm trying to do is I'm adding the previous value to the next value. The previous value in this case is starting from 0. That's my assumption. The next value is going to be my minimum value. The next value is also going to be my minimum value. And then the previous value is going to be what sum plus my minimum value is. So if I execute this code, let's try to run this code. Oh, jeez. So you can actually write your logic around any problem. It just depends on the way you interpret the problem. So I don't want to change the problem I've written. So yeah, I'm not incrementing minimum value actually yet. Right? Yes, that's intentional. Okay, fine. Let me implement it. So minimum value plus minimum value plus 1. Let's try it. So then that means I'm going to be increasing this, then it's going to be increasing, then once you get to 10, it's going to stop execution. So now let's try printing this. While loop, okay. So that's the name. So let's say the result of while loop is while loop like this. This is our function, right? That's what we want to have. So let me add a semicolon to this and then try running this program. Okay, this is going to fail because this is greater. No. Okay. So if we run this, what's the error we get? Oh, minimum value should be mutable, right? The reason is because we are trying to mutate the value of minimum value, but we didn't make it mutable, right? So what we're supposed to do is to mutate this value. So that's because we are changing it here. That's why I didn't want to change it before, but then now that we are doing that, let's have this here, right? And then we have this mute keyword, and then we have this minimum value being incremented, right? Someone is saying something. Yeah, exactly. With some, no, I'm not incrementing some actually. Some is just going to work at this point here. So some is being incremented or being updated here. As you can see, I'm not even printing anything out. I just want to show that it doesn't throw an error first. We are still coming back to the code. So that's why I'm not printing this yet. As you can see, I'm not printing any value. So once this code runs, nothing will happen. But I just want to be sure that it doesn't throw an error in this case. So it throws an error again by making some, oh, shish. The sum is also needs to be mutable, right? Because what we are trying to mutate sum at this point too, right? So then you can see. So now, let's see. It's still, our code still fails. What is making our code fail? Cannot be formatted with the default formatter. So the result. So now, because I'm not returning anything in this case, right? You can see that it gives me this error. This doesn't implement standard.format display. Now, the reason for this is a, okay, one way to print this now. This, I think this is the first time we encountered this error. So now let me explain why this is throwing an error. Now, because I'm not returning anything, like I said, I don't plan to return anything from this function yet, right? But if I want to fix this, let's say I want to return a value, a U8, for instance, or let's say I want to return a U32, since we are not defining whatever value we are returning, and I'm returning sum in this case. Now this is perfect. So I say return sum like this. Now let's try running this. Now you can see that there's no error anymore. We are not getting an error. And like I said, now that I'm returning a value, you can see the result of sum is what? 45, right? So, but initially I was not returning a value. So now let's take it back to that part where I was not returning a value. I want to bring something out from there, but let's first analyze this. So now you can see that from this logic, what we are simply doing is whenever we add this, whenever we increment this, we are simply adding the previous value to the next value. And then you can see that between 1 and 10 is giving us 45 as a result. I don't know if that makes sense. Right. So now it simply means I'm having 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Right. And then I get my 45. So I think that is clear enough. So that is what a while loop helps you to achieve. So in this case now, what I'm simply doing here, right, is to get 1 plus 2 plus 3 plus 4 continuously like that until I get 45. And I know that it's not going to add 10 to it because I said once it's less than 10. But if I change the logic to include 10, what do I get? I get 55. So let's run that and see. You can see I get 55, right? Because now I'm saying that include 10 to the while loop. But once it gets to 10, it's going to break out and then return nothing for me. But in this case, I don't want to return a value, right? I don't want to. I want to just have it run without returning a value so that we can see that same error again. Now, it's not actually an error per se because we know what to do to fix it, and it's quite intentional. But you can see that it gives an error about why is this complaining? I'm still using this bracket with this guy. Wow. And nobody corrected me here. So in Rust we don't use that at all. So just try to it's just JavaScript that I've kind of been used to writing those things like that. Now you can see this error here. So and it says this does not implement standard.format.display. Now this is going to come up in our later classes because this is a type in Rust, right? It's a type in Rust, it's a bracket. But then you can't just print that directly if you want to print it, or if you want to print a type that is not a basic data type in Rust. So that's one thing to point out. If you want to print a value or the result of a function that is not a basic data type in Rust, what you need to do is not just to pass in this curly bracket like this. You need to pass in this, a colon and a question mark, right? So Rust, once it sees the colon and question mark, we'll know that, okay, this needs to be formatted, but it's not a basic data type. That is not a simple data type. Then it needs to now check which data type it is first, and then implement a way to return or print it for you to the console. Now let's try printing this again and see. And you can see that we don't have an error anymore, right? And you can see what it prints for us. It prints this for us, meaning that this is a data type, like I said. So it's printing this. If it was also a struct, now this is not a simple data type. That's why it can't print it. Now, if you are familiar with formatting in other languages like Python, you'll be used to this question mark format, right? It's simple. It's simply a way of formatting that is being passed to programming languages. If you want to format in decimals, or generally, if you are used to other languages, you must have seen this once or something like this in formatting. So it's the same thing that happens in Rust. So, but in this case, because it's not a simple data type like strings, like integers, like booleans, like characters, data types, you need to specify that the compiler should infer the data type that it is and print it for you. Does that make sense, please? Is anybody confused about this that I just wrote here? Or it's clear? Should we proceed? I believe nobody's confused or not lost at this point. Okay, so now I think this is clear, right? We are good. We're good on this. Okay, so now that is what we have. So I want to show that error again to point out something else. And then you can see that it says it doesn't implement standard.format.display. So that means just note these errors. I don't know how to make you remember this, but just try to put it somewhere in mind, because we are going to see this in later videos. We are going to implement this. So that means there's a way you can implement your own trait. Now, this is called a trait. Just put it to mind. Like I said, we are not doing that now, but have it in mind. It's called a trait. And the reason why it's called a trait is because the trait standard.format.display is not implemented for the parentheses. So that means we can implement a trait for that function and make it print normally the way it should print. But don't worry, we'll come to that. Just have it in mind, right? So that's what I wanted to point out. So now let's return the formatting syntax for this, and then just get it to work. So while we have this, then we have the result of while loop is this. That's just what it is. The result of the while loop is the brackets. Okay, so now we have that JavaScript. All right, so that we've been able to successfully execute our while loop, right, program. And you can see that this is similar to what we have. Okay, where's so it's similar to what we have here. What we have here, right, but it's different. This is, you can see that we have different logic, different execution, different logic in this case. So it's similar, but it's different. So this place is just incrementing the value of I, right? And we are incrementing the value of the minimum value that we want to keep adding. So the logic will determine what the result will be and what you write in your code logic. So that's that. So, and then you guys saw the mutability, where it works or where it comes in this code. Remember, I was not making this mutable before, but I was trying to assign a value to it. And Ross kept telling me that, no, you can't do that. No, you can't do that. No, you can't do that. Now, you'll have noticed that while using Ross now, there's a way it helps you to reduce having variables you don't use because you complain. It helps you to prevent accessing or mutating a variable that you don't have access to, except you specify it. So all of these things are what makes Rust preferable when it comes to efficiency in programming language. And it has come to that point whereby we are more efficient, right? We need efficiency in everything we do because there's a lot of, we are moving daily, we are advancing in technology, but we need to be more efficient. So Rust helps you. Of course, it's not as JavaScript or other languages like Python that you just write, you have flexibility to do whatever you want. In Rust, you are actually constrained, but the constraint is good because it enforces you to follow the rules of programming, like as it should be, right? So if you meet people that have written programs for years and they have more experience, decades of experience in programming, they will tell you that programming languages have been flawed because they don't follow the principles of languages. They just make it work, just write something to work without following the principles. So I know that if this is a bit confusing in terms of like syntax or having to understand why do we need this and this and this, it's totally understandable. You have been used to a system that does not force you to do things in a certain way. But having to write Rust will force you to think of how you write your programs. And it will reset your understanding of writing code the right way. And that's very true, right? It happens to everybody. So once you start getting familiar with it, you will start liking the way it constrains you. Not really constraints. You will start writing it in the way it should actually write your code. And then you begin to have that flow of any code you see or any Rust program code that you can encounter. So I just wanted to introduce that because I know that we are getting to the more complex side of it. So yes, so that's that. We've covered the while loop. So let's look at for loops, right? So now we've covered branching, panics, loops today. So I think we'll finish this also before we move into the next topic. Okay, so now let's go to loops, right? So we've covered the while loop. So while loop is just one of the loops that we have. So like I said, if you are familiar with other programming languages, you're probably familiar with while loops, for loops, do while loops in other languages, while do loops in other languages. But we have the while loop in Rust also, and then we have the for loop. Now, the for loops also, in Rust, we have two types of loops. We have the for loop, and we have another type called the loop. Now, we are going to look at both of them, but let's start with the for loops. Now, for the for loop, which we have, so I'm going to define a function called for loop, and then implement certain logic within this function. Now, the for loop is a way to the for loop basically is a way to execute your code logic multiple times. So let's say I have a code, if I have a function here, I have a function, right? Let's say that print is a function now. We've established that print line like this is a function. We've established that, right? So I have a function that prints, or let's say you have an exercise to print a value 1 million times. you get now. You don't want to have print. This is the value to print 1 million times. You don't want to have something like this continuously. That's what you plan, and that's not what you want to do actually. So, but in this case now, say you want to print this 1 million times now, what you could do is just use a for loop. So a for loop helps you to execute a code block or a code logic multiple times, right? That's what it does. Now, if you are familiar with okay, the best way to describe this is, okay, looking at this, say you have like a logic, right? Okay, fine. Let's take this print line first before I move to that one. So you have this print line, and then you want to print it 1 million times. What you need to do is to have a for loop. A for loop in this case will help you to keep executing the logic within the body of the for loop until the condition is not satisfied, right? So a for loop will keep executing the logic in the body of the for expression until the condition is no longer satisfied. Right? So that means the for loop, just like every other syntax we've touched today and we've explained, has a for keyword, right? Then once you define your for keyword, you need to define your condition, right? Then the body of the code. Body code, your logic to be executed if condition is true. This is the syntax for your for loop. So in this case now, the condition is going to be what? These are the syntaxes. So that means the for loop, for the for loop, your condition is, say you have, your condition is to print this 1 million times. You need to have a way to say between 1 million. Right? Between 1 and 1 million. In this case, I can write my 1 million like this. I think I mentioned that last week. I don't know if I mentioned it, that you can write this to make it easy for you to understand large numbers in Rust. You can use the underscore to separate values, and it's totally valid, right? I think I mentioned that when we were talking about constants. Yeah, last class I mentioned that. So yeah, so but this is valid. So I can write it like this as 1 million, but I get confused with the numbers if I do, and I can also do this, and it's valid. So I can say between 1 and 1 million. Now what this means is I'm defining a range, right? Because I want to print this 1 million times. So I simply want to instruct the compiler that I want this to be printed 1 million times. So that means have a number from 0. That's what I want the compiler to do. So I want you to have a number from 0 to 1 million. Or I can say from 1 to 1 million. Still the same thing. So, but if it's 0, that means, and I want to print it 1 million times, then I have to 1 million minus 1. Because from 0 to 9999999, that's the value. But if I wanted to get to 1 million, I can just say from 1 to 1 million. So it depends on what I want. So in this case, I can say for 1 .1 million, let me use this. Right? So that means it's going to print 1 million times. I want you to print, what's the code logic now I want to execute? Print this 1 million times. Right? So in this case now, this is a perfect implementation. It's going to execute and print it 1 million times, but come on, I don't want that to happen. So let's say I want to print it just 10 times, right? Or 10 million times too. I can do it. So that's the syntax for a for loop. So it allows you to keep executing a code logic for an expression, or for a condition rather, until that condition is no longer satisfied. So the condition that is supposed to, the logic that's supposed to be executed when the condition is satisfied, will be inside the scope of that for loop. Now, are you guys going to see a pattern here? There's always a scope for everything that you want to do. In this case, for a function, there's a scope. For a new statement, there's a scope. For a while loop, there's a scope. For a for loop, there's a scope. So it's basically a scope for everything. That is very important, right? Now you can see the for loop here. So for elements in iterator, then you have all of these stuff, right? So now, how do you implement this that we want to do? So let's say we want to run this code. Want to actually show this 10 times. Now let's do this. let's actually run this. Now, using this analogy that we have, we want to run it 10 times. So let's say for I in this value, right? So we just want to print this 10 times now. So you can see an example here for elements in iterator. So that means you need an element in this case, and then you need an iterator, which is more like the condition that you have. So this basically is your condition. So you can split the condition to element and iterator. So now in this case now, we have to talk about the range, right? So Rust library provides a range type that you can use to iterate over a sequence of numbers. So given the example I have here, if I want to print this 10 times, so let's try, let me add this to the for loop, print, let me just do this for loop, right? And execute this. Now you can see this now. It's printing how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? The reason for 9 times is why our code. Let me collapse this. Now we have 9 because it starts from 1 to 10. Now, interestingly, you can do it like this and to print 10 times. Let's check out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Let me highlight this so you can see 9, 10. So this is 10 times now. So it's printing 10 times. Now, that means I can define my range of numbers, right? And say that I want it to start between network, I guess. Screen is no longer showing. Okay, it's back. So I can have between 1 and 10 in this case, or I can have it between 0 and 10 in this case. It's still going to print 10 times, right? So now what does this thing mean? This syntax that you see here. I'm simply saying that for I is the element in this case. This is the iterator. This is the entire condition I'm trying to execute, right? So I'm saying that for I in 10, like it's going to go through this range. So when you run a for loop, you pretty much want to go through a range, just the way I was explaining this the other time, between 0 to 1 million, right? Let's say 1,000 in this case. You know that I need to run it 1,000 times. So now that means there's a way to do it in Rust using the range that Rust provides for us. So now how does that range, now how do we write it and how does it work? So how it works is you define an upper bound. So for range in Rust, right, you define an upper bound, a lower bound first of all, and an upper bound. Now, what do you mean by lower bound? Lower bound is where you start the range from. Lower bound, the beginning of the range. And the upper bound is the end of the range. Right? Now, but in Rust now, there's a syntax called, so you can have your upper bound like this. Lower bound, dot, dot. Now, the dot, dot here is you see saying that start from the lower bound to the upper bound, right? And you can also have the equal to. So now let's analyze what the dot dot means. So the dot dot in this case now means that what include from the lower bound to the upper bound minus 1. That's the meaning of this. But the moment you add your equal to in this case, it simply means that what include the upper bound, no longer minus 1. So let's do this way. Include from the lower bound to the upper bound. Now without the minus 1 in this case. So that's why if I add my equal to, so if I have something like this now, let me give an example. So an example in this case is 0.5. 0.5 in this case simply means 0. Don't forget that 0.5 in this case means include from the lower bound. What's the lower bound? 0. What's the upper bound? 5. So include from 0, right? 1, 2, 3, 4. It will include 5. Reason is because I said include from the lower bound, which is 0, to the upper bound, which is 5 minus 1. So it's not going to include 5 in the range. I don't know if you get this. Does this make sense to anybody? Is it clear enough? Okay. Is any other person lost? Anybody confused? I think it's only Jude that is. Okay, that's clear. All right. So that means if you have this now, so that means we have the okay. So we have this range now, saying that from the lower bound like this to this upper bound minus 1. But if you have an example like this now, let me try to duplicate this. An example of this from this to like 7. And I add this to it. What does this mean? It means I'm going to add 4, 5, 6, and 7. Why? Because I'm saying that include 7. So this equal to simply means include the upper bound, right? So that's the meaning. So now if you see something like this now, and I have this, it simply means start from 0 and continue incrementing it until you get to the upper bound, which means 10, right? But if I remove this, it will not get to that value. So does this make sense, please? Are we clear? I assume you are all clear on this. Okay, so now this is how to achieve this. And you can see the implementation from, you can all see the implementation from the execution that we had here, right? Printing it multiple times, and you can see the result perfectly displayed there. All right, so we have all of those things. We have the for loop, we have the while loop. Now let's consider the last type of loop, right? Before we wrap up today. We'll wrap up the class. Sorry, excuse me a minute, please. Okay, now let's proceed. So, sorry, excuse me, please. Excuse me, guys. All right, sorry about that. I'm back. So yes, so let's touch the last one. We can cover the other loop. So now this is how your loop works. Like this, just like this general syntax for your loop with all of these explanations. I know the explanation is a lot. I've explained a lot about that. I don't think, well, I think it's just explanatory enough, right? So let's go to the other type of loop that we have. So now, yeah, this is the explanation. They have open loop, inclusive range, open-ended range. Oh yeah, I forgot to mention that if I have if I don't specify an upper bound, right? An upper bound, let's say for example, if I don't specify an upper bound, in this case, I forgot to mention that. Let's say I just write something like this. It's going to keep running until infinity. Like it's going to continue running until infinity. So like forever. That's what the mean. That's just the meaning. So it's going to continue running. But if I don't also specify a lower bound, let's say I don't specify a lower bound. Let's say I have 100 and I don't specify a lower bound. It's going to start from 0. That's the meaning. So it's going to start from 0 and take it up to 100. So whether you specify or not, right? Whether you specify or not, so this will be 99 rather, because I'm not including the 100. So whether you specify the upper bound or the lower bound, just know that the lower bound by default equals to what? Equal to 0, right? And the upper bound by default is equal to infinity. Sorry, I don't have the infinity sign on my keyboard. I will have written it for you guys, but it's more like that sign. You guys understand the infinity sign here. So yeah, that's the sign. So the infinity sign is basically what you have. So yes, that's everything about the for loop. Now let's touch on the last kind of loop quickly, but I want to cover loops today so we can go to a new topic starting next week. So the other loops is not defined here, but let's check from the main Rust book, right? So for that loop, let's see. Let me use this to explain the loop, the other type of loop. So for the other type of loop, let's see where is it? Okay, so let's see the loop. I think we have the loop here. Not the for loop in this case. No, not this. I think the loop labels. Okay, no, not this. So it doesn't give me what I want, but there's a loop that I want to use. I think I might just have to keep that in next week. I don't want to keep us more on the call. Let me search for it. Okay, no iterators. Definitely no iterators. Oh, jeez. Okay, so control flows. Where is the loop in this code? This program, this book used to be somewhere around here. Oh, here. So exactly, this is it. So this is what I'm looking for. So you have repetitions with loop. So this is other type of loop, right? So define the first loop, which is the for loop. Now we have another loop type, which is this, right? Which is this. Now this is like peculiar to Rust, right? Sorry, excuse me, please. So this loop type is peculiar to Rust, whereby you have this loop, and then this keeps running forever. So now, if I have this now, let's try running this. So I'm not going to run it because it just run forever, and then I'm using an online editor, so it definitely crashed the browser. So I'm not going to run that. So I just wanted to show you guys, right? But we can run a type whereby we can control. We can also control it. So let's say we can control using something like this. So now let's say we have something like this. Let's check the second type of loop. We can have this. Now this loop simply means start running a loop that starts and runs forever. That's the meaning, right? So it simply means run a loop that starts and runs forever. So now, how do we explain, how do we use this now in real life scenario? Let's say we want to bring something like this for loop that we have here. In this case, we can have something like print line in this case and say this is the value to print 1 million times. The same thing, right? Now, the difference between this and this is that from beginning of this, from initialization of this loop, from defining the loop, we are specifying the range. But for this one, once you specify a loop like this, it just keeps running forever. It will keep running forever if you do not break out of this loop. So you need to be the one to break out of this loop by specifying a break like this. So if I write this code now, it's simply going to run once, right? Because I'm breaking out of the loop, immediately I'm writing it. So now if you count this, let me make this change. Let me add something to it using the loop. What do they call it? You still say loop, so I don't know. Let me say using the loop actually. So then let me run this. Okay, so let me run this now. You can see that I have that just once, right? But if I want it to run 1,000,000 times or 10 times, I can use a counter to catch it. And I can use a counter like this. Let counter or underscore counter equal to 10. And I'll say that counter equal to 1. So I'll say if counter is greater or equal to 10 rather, then it should break this guy. So if I run this code now, I'm expecting it to print. Let me make it 5, not 10. So if it's okay, right? If it's 5, it should break out of the loop. So now if I run this, cannot find value counter in this code. Oh, yes, cannot find it in this code because I'm using underscore counter here. Sorry. So now try running this. Now we can see that. Oh yeah, keep making a mistake again. I forgot to add the mute to it because I'm increasing it by 1, right? Obviously, I'm writing to the variable here, so I need to mutate it. So if I do this, and then I'm just going to run. I'm not performing streaming. Oh, geez, it's gonna running forever. Close. Let me remove this first of all. Let me remove this. Let me just break out of it first. Okay, so let me make this break exactly. So fine and good. So now, right now, let's check this example here. Just use it to explain. So you can see that we have this, right? So we say this is the loop. If counter is equal to 10, breaks this. Now we're not touching the multiple loops for that. I just want to use it to explain. I think we might need to take this next week because we have examples. But we have this as a loop. We have a counter being implemented. We have, if the counter is equal to 10, break out of the loop, break counter times 2. But basically, this is just the way you check out of it, normal. But probably because you're using the online editor, it's not trying to run it multiple times. I don't know. But then it's supposed to work for you. But then, because I'm using this online ID, right? But this is how you break it once. But this is how you continue to check that multiple times. So let's say I have this as oh, I said 5 here. No, it's still specifying it. So I said if is equal to 0, if is equal to 5, break out of the loop, right? We'll add this to this. So the reason why it fails is because I'm saying that this is 5. I'm incrementing this before this, and then I'm expecting it to break. So that's why it failed. So it's not even, that's nothing to do with the ID part. So what this means is, let's move this. Let's make this 0, right? And then this should work now. Yeah, so this works. So you can see it printed 5 times, right? So the ID is fine though. It's just the logic we wrote before. So the logic we wrote was incorrect. So that's explained this. Also, you can have like what this example is trying to do. You can have it like an expression also, just like we have the for loop as an expression before now. You can have let's counter result equal to loop. Let me close this. Can have this and say the same thing, print line. Okay, let me just copy this. That will write it. Okay, you can have should I use the same counter? I've run out of examples in my head. All right, so what the idea is you can have counter plus this, and if counter equal to 5, break also. So it's probably going to just like return the value, but in this case, I don't want to return it, right? So, but if you check this now, the result is going to give you the result of counter. That's so if I break this counter like this, no, I need to specify this. So the result is going to be a value of what I'm returning after the break. Now, in this case, now because I'm breaking this, just like we have here, so we see how we can print it. But in this case, now we are breaking out of the loop here. But the challenge is not challenge now. What you need to add to it now is whenever you are using an expression like this, you need to specify what you are returning. So after the break keyword, you need to specify the value to return to counter result. I don't know if that makes sense. So that's what we need to do. So in this case, if I run this now, okay, like I said, whenever you write an expression, you need to also end the semicolon. I don't know why I keep forgetting this today. Well, now you see now this, so you can see that this runs how many times? This runs 5 times. This runs, oh, because this one is already 5 at this point because we incremented it here. So it's just going to print only once here and break out of the loop. And then it's going to return the result of this. So if we print the result of counter like this, right, and say the result of counter is counter result like this. Now let's print this, but we can't use this anymore because so I'll remove this here and they just print this since we don't want to implement counter, so it will cause an infinity error or a streaming error like the other time. So if I print this now, you can see the result of counter is 5, right? Because I'm passing the value of that loop into this place and I'm returning it from the break that I have here, right? So I just wanted to point that out. Also, one thing I forgot to mention, not really forgot to, I don't want to talk about it yet, but you can have nested loops and you can have labeled loops. Now, labeled loops in the sense that if I go to the first loop example I have here, right, like this, this is just a simple, straightforward loop. So I can have this loop, like I can have labeled loops. What do I mean by labeled loops? I will have the loop with other loops embedded inside, but then all the loops will have their own labels such that I can call any of the label of the loop to identify which loop I'm referring to. So let me show you an example, right? I won't show, like, I won't undo or implement any example, just to show you how it works. So assume I have this type of loop like this. Now this is the name, this is the label for this loop. We call them loop labels or label, I call them, okay, label loops, loop labels. So to disambiguate between multiple loops. Now, if you have loops within loops, right? So you can use that to specify which loop you want to interact with. So most languages, most low-level languages have this functionality, most of them. And even low-level code, like very low-level code, have this functionality whereby you identify the conditions you are trying to make reference to when you are executing the code. So this is just a way to make it easy for the compiler to understand that, okay, this is what I want to break, or this is what I want to continue to execute. So in this case now, this is a perfect example of how to label your loops. You add the label before the loop by using this, right? Now, in this case now, we can see this outer label have this mark here. This mark in Rust is always used to identify lifetimes, but don't worry, don't let us go there. But just know that this is how you write it. You have a variable, right, that is used to identify, or a label in this case, to identify this loop like this. And then this loop that we have here will contain logic, which might have other loops, right? And then the loop within it also have its own label. In this case, if you want to add a label to this. But now, because we already have just one loop, if you have two loops, you can label the loops within the parent loop and then make reference to it. So what this means is that within the second loop, this break will only make reference to this one, or this second break will make reference to this one, because I'm specifying that break this label, and this label has to do with this guy. You get, so you can have much more complex loops like that, like much more nested loops, which you can have a lot of them, but it does depend on the logic. It's always a way to streamline your logic, but I just wanted to point that out. We have that in for loops, we have that in loops basically. So yeah, I think that's what I wanted to point out for the loop. So this is another way of having loops in your Rust program, right? And yes, that is that. So any question for today before we wrap up the class? We've spent extra time. Sorry for that. Sorry for the delay. Any question before we wrap up the class? I'm going to assume you have questions, but you don't want to ask. Any questions? I'm going to assume no questions. Okay, so I assume everybody go with it today, which is nice, which is nice. I think I like the fact that you guys understand it, so that's impressive. All right, so thank you. So the questions, okay, said thank you, Silent Killer. Oh, thank you so much, Shaibu. Thank you too. And which platform is best to practice? So I think as always, this is what I tell everybody I tend to explain things to, my students and every other person that asks me these questions. The best way to learn these things, right? Personally, I'll tell you my own way of learning this. So when I started learning Rust, it's more like, okay, what do we need to understand? And like I've always told you guys to first try to learn the syntax first. So, and I believe the best way to learn it is to pick up a simple exercise. Like, let me show you this one I'm using. This 100 exercise to learn Rust is a good way to start. The reason is because the exercises, they are simple. Now, the Rust book has the best documentation you can use for anything, right? For learning Rust. But then it can overwhelm you if you don't understand it, if you are starting up. This was what I started with, and it kind of, it's a very explanatory until you get to Hello Cargo. Once you get to Cargo, before installing, we've not even done this installation yet. I'm still using an online ID, right? It's very understandable until you get to start using, start writing what is io.std.in.readline, and you are confused and you don't even know what string is and new is. It just pushes you inside direct. So while it is good and that's the best resource, it can be overwhelming for a beginner, right? So I tend to use or I tend to use other resources that have chunks and tend to simplify the code. There are a lot of them, but the one I use currently, there's one I used to use before by Google, like Rust exercise made by Google. I can't remember the name now, and I don't have it currently, but I will try to get it and share it as well. And then I use these Rust exercises. Let me send the link. It's simple enough to understand. So while you are still learning, right, it is perfect. That's for exercises, for documents. And like I said, the Rust book also. And then I use this one, Rust Labs also. Rust Lab is it's very simple too. Like if you are trying to play with different exercises and understand it in depth. It gives you a lot of things, right? But it simplifies it a lot for you. So it helps you to start up, then you can move to advanced resources. So I'll send this also, rustlabs.io.github. So I'll send you this. You can try this also. And then the Rust book, which is the most important one, I'll send this. And let me not send the guessing game. Let me just start from here. All right. So yeah. So these are like resources I recommend for you to start up because they have practical exercises to start with. But the Rust book, I will advise you just for references, right? For now, until you are very familiar with it, and then you just need. But still, you still always go back to the Rust book for references. You will always have to because changes as new concepts are coming out, and then it contains a lot of information, like very detailed ones, especially for advanced concepts. You need to go there to make references. So those are the resources I would recommend first of all. But then, for videos, right? I don't usually watch videos to learn this kind of things, but the one I would recommend for you, Let's Get Rusty, is a very good resource to start. He has a series of Rust's how to begin writing Rust. It's a very comprehensive one. Just search for Let's Get Rusty on YouTube. It's a very popular one, like it's a very popular channel. It helps you to like learn Rust a lot. So it's on YouTube. You can, yeah, I think this is it. This is the series Let's Get Rusty. So it's one of the most detailed, the one I use though. So this is the one I use. There are other ones from FreeCode Camp and all of those things, but I just stick to this and it helped me when I started learning it too. But then I had to go back to documentation and all of those things. So he has a lot of information about Rust and you get it. So that's basically it. So there are a lot of places you can learn it. So just search for Let's Get Rusty on YouTube. You see the guy's channel. They're very popular channel. And yeah, I think those are the ones I recommend for you to just get started. Yeah, so that's that. And also, I think, yeah, that's it. Just try hands-on exercises. Try to go back to what we've done. Try to work out the exercises. The basic data type, like I always say, is what you need, right? So because for instance, let me give you another instance. Say you want to build this game now, this guessing game here in Rust. It's very easy to do actually. Like you can build this in 10 minutes, less than, in fact, if you understand the basics. So what do you need first of all? You need to understand that first thing you need is, okay, in print line, you know what it is. We've not started using libraries, right? But when we use that, you understand. You can still actually understand if you follow this documentation. And then you have this secret number, which is you already understand what this is, this range, what this means, right? So you might not understand what this is because it's a library. So a library tells you what to do. You don't really understand it until you go and study the code. So, but this is just the way it is implemented. But you understand the prerequisite, which is what this is. You know that this is a mutable variable, right? You know that this is to get impute, even if we're not talked about it, right? But basically, with all these pieces that you can use it to get impute from your terminal, from the user, right? That's a perfect way to understand that. And then we've not talked about match, but we're going to talk about match statement. So by the time you understand all the simple parts of these things, it begins to make sense to you as you build to more complex programs. You get it now? So like I said, Rust is not difficult, but okay, look at the loop, for instance. You can see a loop here. Let me increase this a bit. You can see a loop here in this case, right? So you understand what the loop means already, right? So this will keep running forever. That's the meaning, because there's no break anywhere. You understand that, you see it, you understand what it means. Then you understand that after that, you have this, okay, we've not talked about this too, but then we are still going to talk about it like very, very soon. And you can see that everything is used within a loop. You can see the range. You understand that you break. You understand now, okay, that is break now. You understand that the loop will break out of this once it gets here. Do you get it now? So it's just a lot of building on simple things that you have. That's just what it is. So once you understand the basic concepts, right? But before you start talking about concepts like ownership and borrowing, references, all of those things. Once you understand the basic ones so well, you can start dwelling more on those ones. And I can assure you, it just gets simpler from there. So that's the idea. So that is it about Rust. That's it about today's class. So sorry for taking your time, everybody. I know we overshot time by 19 minutes now. So, but thank you all for staying on the call. Thank you for being a part of the class today. Appreciate it. And so I'm going to release the video recording for today's class today. So once after a few hours now, I'll get it, process it, and push it to YouTube, and then I'll send the link. And I'll share the link on YouTube so that you guys can see it. Also, what I'll try to do from next class, I think I'm going to have a site running for this. I'm going to share it on Twitter. I've not done it yet, but I will have a site this week whereby you guys can, like, if you have questions or new informations, can be on the site. And also, probably there will be a group for these Rust classes. I'm thinking of creating one. It's just that to manage it is, I'm trying to work my time, so I won't just create it and neglect it, right? So I'll create that group for these Rust classes so that we can join, and yeah, we can get information, direct information from there. So it'll be more like, yeah, for the Rust classes. So I'll create that, but that'll be, I'll give more information in the next class, right? So the next class by Monday, 8 to 10. So watch out for the information during the week, if there will be, but I'll definitely create the website for this all classes this week, so that for formality, and then you guys can go there and see new resources, check the videos from there directly, and any new information will be there, definitely. So yeah, that will be all from my end today. Thank you so much, guys, for joining the call and the class today. I am sure you've learned something, so please try to continue practicing this. It's very important, please. I'll stress that a lot. Practice is what makes perfect. It's normal. It's a law practical in this world, for anything, for any language. You don't practice it, you forget it. Every language is simple. Trust me, there's no language that is difficult in this life. But if you don't practice, you will forget. If you don't try, you will forget. Even if you are writing binary, if you don't practice it, if you start practicing binary today, I can assure you in 3 months' time, you'll be writing binary code, top of your head, if you keep practicing daily. Assembly language, everything works. You just practice. So please and please, practice what we've done, practice exercises, and trust me, just begins to work for you. So yeah, that will be all. So once again, thank you for joining the class. That will be all from me. Yeah, see you guys next week. Bye.
Bye. Thank you so much.
Yeah, thank you, Judith.
Thank you, sir. Thank you, sir. Thank you, boss.
Thank you.